What's up, y'all? Welcome to the video. Today we'll be continuing the Souls-like combat series with our target locking system. In the last video we left off with visualizing our health and damage system with some UI widgets. And for this video we'll cover how to make our player lock onto enemies, how to change which enemies we lock onto, and how we can implement different dodge maneuvers that you may see in an actual Souls-like system. With all of that said, let's get right into it. For this system, the first thing we're going to start coding up is a target lock component, and this is going to be a UActor component that we attach to our player character. First, looking at the header file, we're going to need some methods for toggling our lock, generating lock queries, getting new targets adjacent to our current lock, and disabling our lock. We're also going to need some fields for referencing what we're locking onto, whether or not we are locked, and some other values which we'll be using for querying our lock-ons. And when I say lock query, by this I mean when our player decides they want to try to lock onto something, we need to find out what exactly is in front of our character for them to lock onto, and so by generating these queries we are basically checking what objects there are in a given space near our player character for us to lock onto. Now getting into the CPP implementation of our methods, first we're going to want these includes toward the top of our file, and the first method here will be generate lock query. This is going to take in a beginning location, the forward direction of the query, the range and radius of the query, and whether or not we want a debug visual of it. Getting the actors in front of us is very similar to how we implemented the damage collisions, where we use a multisphere trace using the given arguments of the method. We then check all hit characters, leaving out the player of course, and the first valid character to be returned will be set as our target locked actor. In our getNextTarget method, we'll be taking in a float which will determine which direction we'll be looking adjacent to whatever the current locked target is, which can be left or right. And if you aren't currently locked onto anything, then the method will just simply return early. However, if you are currently locked, it's going to generate a new lock query with the given parameters to see if there are any adjacent targets. Disable lock and toggle target lock are both pretty simple, with the lock disable acting more as a reset. The toggle, however, will either call this disable method or generate a lock query in the forward direction of the camera relative to its position. Now that we have these methods implemented, we'll be able to manage what targets we're locked onto, but we still need to implement the player character's behavior when we are target locked. And so we'll be putting that in the component's tick method right here. We'll first check if we're locked and that the locked actor is valid, then we calculate the rotations for both our player controller and character, and then set those in the player. Now this is everything we're going to need in the component itself, but now we need to head into our player class and bind these methods to an input so we can call them during gameplay. First, in our player's header file, we're going to add a reference that'll point to our target lock component, and then add a couple methods here which will bind our inputs to for calling on the component's methods. In the toggle target lock method, we're going to first validate that the component exists, and then just call upon the component's toggle method. In the lock on next target method, we're going to validate the component again and make sure that we are currently trying to lock onto another target from a locked target, and then call upon the getNextTarget method, passing in that input value. And lastly, to make sure that these methods work and get called properly, we're going to have to set our component reference here in the begin play method and write these input bindings, which we'll be adding into the engine in a second here. Now back in the editor, we're going to go and add our input bindings. So we're going to go to Edit, Project Settings. I'm going to go over to our Input tab, and we're going to add a new action mapping. We're going to call this Target Lock. And we're going to set this to be the middle mouse button. So if we go down to mouse, middle mouse button. And then the other one we're going to need is a axis for the mouse wheel, and this is how we're going to be using the getNextTarget method. We're just going to call this mouse scroll, and we're going to choose mouse wheel axis. Now the last thing we need to do to at least test our code is we're going to have to go into our hack/character. We're going to add a new component, and we're going to make a target lock component. And on this side right here, we're going to keep these as our defaults for now. We can play around with the values in a second here, but we're going to turn debug mode on so that we can see a visualization of our target lock. So if we compile and save, and if we go to test this, we can see that it is way too short and not big enough. So we're going to go back and we're going to play around with some of those values. Instead of 100, we're going to let's try 800, and a bigger radius, let's try 400. And it seems now we're able to lock onto the target. If we try to go into either side, we can switch targets. And I know the movement looks a little wonky right now, especially with the animation just being the normal run method, but we are going to make a blend space in a second here to accommodate for that. However, before we go and do that, we're going to want to first make a visualization of where we're target locking. So first, what we're going to do is we're going to go into our UI folder here, and we're going to create a new user interface widget blueprint, and we're going to call this BP lock UI. And this is the little icon that's going to show at the center of our enemy when we're locked onto it that you usually see in Souls-likes. So if we're going to go into canvas panel, and we're going to go into our assets here, UI, we have a target lock UI right here. Make that a little bit more circular. Going to anchor this to the center. To zero that out. And just center this just a little bit more. And we're gonna make a reddish tint. Now that's everything we should need on the design aspect of things. It's basically just a colored circle that we're going to show on the enemies. We're going to go into the image and we're going to add a binding to the visibility. And the way that we're going to determine this, we're going to need a few things. We're going to need a reference to the owning actor. Is locked, and this is going to be the slate visibility, and that should be everything we need for now. So what we're going to do is we're going to get the player character, we're going to get the target lock component by class, and we're going to look up our target component. If this is valid, we can keep going. And the way we're going to check for this, if the owning actor is equal to the target locked actor, then we should show that these are visible. So pull this back a little bit. And so if these two are equal, then is locked is going to be set to visible. But if not, it's going to be hidden. And then once we get to the return node, we're just going to return this right here. And that should take care of the visibility. Now let's set these up in the enemies themselves. We're going to go over to our AI tab, our characters, our BP enemy. We're going to create a new widget component. I'm just going to call this target lock. And we use the class BP lock UI. Come on over here. We'll scale this down just a little bit, maybe 0.5. Bring it up just a little bit, that should be fine. And in our event graph over here, we're going to pretty much do the same type of thing we did with our health bar for setting the owning actor, but with the target lock. So we're going to get our target lock, get widget. I'm going to cast this to lock UI. And set the owning actor to self. Now when we go to test this, when we lock onto our target, we'll see the UI is showing, and it's properly showing based on whoever is targeted. However, there's a little small issue that the UI is kind of not see-through. It's kind of clipping through the enemy. So we're gonna have to make a change to the material in order to fix that. And in order to fix that, we're gonna go back into our BP enemy, into our target lock UI, and you'll see we have a default material here that the engine gives us. We're going to browse to that in the content browser, look up widget, and we see we have all of these defaults here. What we're going to do is we're going to make a copy of this right here, and we're going to make some edits to it. So we'll just copy paste, and we'll rename this to my widget see-through. If we go into there, what we're going to want to do here is we're going to want to disable depth test. Apply and save that. If we go back to BP enemy, look up my widget see-through, apply that. And now if we go back and test, the widget is now properly seen through the enemy. And so now that we have a visualization of when we are target locked, we're now going to go and we're going to make that blend space to make our animations for our player look a lot better when we're target locked. So if we go into our /assets, we're going to go into night, animations, we're going to go into our blend spaces, going to create a new blend space, and this is going to be on the night skeleton. We're just going to call this target lock BS. And if we go into here, we're going to have something for both our horizontal axis and our vertical axis. This is going to be set to direction, or yeah, direction. And then this is going to be our speed. And the high end is going to be 600, from 0 to 600. And the direction is going to be -180 to 180. And with the blend space here, at the moment there's nothing set in the animations for us to base off of. So what we're going to do is we're going to plop in our night idle right at the bottom here. We're going to then find our run animation, run forward. And we can see we're blending from idle to run. But in the middle there, we're going to want to have our walk cycle. And that should be good. Now to get the other directions going for, say, if we want to strafe left or right, we are going to add some other animations to this little line here. So if we go and we add strafe walk right, this is going to be in this direction of it, because in the positive direction of 180, that is going to be for rightward movement. And as we can see here, as we get faster, we start to walk this way. And we also have one for running right. So as we increase speed, we start to run to the right, back to walking, and running. And we're going to do the same thing for the left. So now when we switch directions, we're now walking this way, running, walking, etc. And then we are now also going to need one for backward movement, which we'll be getting when we go closer to 180. So forward, rightward, backward. It's going to be the same thing on the opposite side as well, as we get closer to -180. We're going to do the same thing for walking. So now can walk backwards, run, and to fill the rest of this in, we're going to add idle states to the bottom of this. And now that we have that blend space created, we are now going to go and update our animation blueprint. We're going to go into BP Night Anims. We are going to add a couple variables here. We're going to need one for target locked. And we're going to have this be a Boolean. And then we're going to also need a value for our direction. This is going to be a float. And we also already have speed being tracked, so we should be all set on that end. Compile, save that. We're going to go into the event graph over here. And first, we're going to want to set our direction. And the way that we get this value, we're going to add a reroute node here. We're going to get the actor's rotation. And then from here, calculate direction. You plug the velocity into there. And then we'll set the value to be that. And that should be all set there. And then the last thing we're gonna have to do is we're gonna have to set target locked. And what we'll do with that is we will get a component by class, and we're going to get our target locking component. And then from there, we just pass this value in, and now those values should be correct. So the last thing we'll have to do to update this is we're going to go back into our state machine, and connected to our walk run cycle, normally in here we just have our walk run space, but we're going to make a new state, and this is going to be for our target locked running and walking. So new state, target locked. And we're going to bring in our target lock BS. We're going to pass in the direction and the speed. Compile, save that. And now we have to just set the conditions for these transitions. So if we are target locked, we'll pass into this Blendspace. However, if we're not target locked, we'll just walk and run normally. And so if we go and test that now, you can see here we are now having much smoother animations that are a little bit more accurate to whatever direction we are walking in. And this is also still based on where we are locked. Now this is going to cover everything we need for implementing the target locking system itself. However, now that we are going to be orienting our player character to look at the target, we're going to need to make some updates to our dodge maneuvers so that we can still dodge in whichever direction we'd like as we are locked. So what we're going to do is we're going to make a new component called an evasive component. Looking at the header for this component, the biggest thing here is going to be all of the different dodge animation montages we're going to need. These include 8 montages for either direction when we are target locked, a normal dodge roll for when we aren't locked, and a simple dodge for when our player hasn't specified any movement direction. We're also going to make a method for executing our dodges and a boolean for tracking our dodge status. Getting into our CPP implementation here, the only thing we need is logic for our dodge method. We're first going to get our player's anim instance as well as their velocity. If they aren't already dodging, then we're going to check if they are target locked. If they aren't, well, then we'll check if they're moving. If they are, then we'll play the simple dodge roll, but if not, we'll have them do the simplest step back dodge. If the player is target locked, we're going to get the directional value in a similar manner to how we got it in our animation blueprint, and we're going to use that value to determine which montage to play. Now that's everything we're going to need in the Evasive component. We just need to head back into the player character file and make some small updates. Similar to how we added the target lock component, we're going to do the same exact thing with the Evasive component, and anywhere we had a reference to our is dodging boolean, we're going to replace that with a component's boolean. And in our dodge method, we're going to replace that with a call to our component's dodge method. Now back in the editor, let's go and add this component to our player character. I'm going to go back into the hack/character blueprint. We're going to add a evasive component. And all we really have to do here is add our montages on the side here. Now, before I go and set these, I'll show you where I got my animations. I got them from this really nice pack from the Unreal Marketplace called Rolls and Dodges. It has basically anything you would need for evasive animations, whether it be sidestepping, rolling, etc. But since the animations from this pack use Unreal Skeleton and our knight uses Mixamo Skeleton, I had to retarget the animations. I already went ahead and did this. If you go over here, you can see all of our retargeted animations in this folder here. And I'm not going to show here how to retarget animations. There are plenty of good tutorials out there on how to do this, but in the description I will link my favorite of these videos as I found it very helpful. So with that, let's go and let's start setting these. So if we go and set just our basic dodge, our falling roll, our step dodge. It's going to be dodge backward here, walk dodge forward, and we're going to get our roll right, get our roll left, get our backward roll, then we're going to get our forward left, our forward right, and the left and right for backwards. Now this is everything we're going to need to set in this component. One thing I will make sure to mention in these different animation montages, it is important that we do include this montage notify right here and just name it dodge. If you remember in our code, we also have a montage notify for whenever they see a notify with the name dodge, it's going to reset the dodge so that our player can dodge again, and this is just how we track our dodge status. So with that, just make sure when you are having your different animation montages that you just have one set towards the end or wherever you want the player to be able to dodge again, set like this. And so now with that, we can go and we can test. And if we go moving around, this is just our normal dodge rolling. If we don't dodge at all or don't move at all, we can do a step back. And now if we test our target locking, we can now dodge in whichever direction we'd like. So there you have it. We now have our target locking system implemented, as well as an improved implementation for our players' different locomotion and dodge animations. That is going to be it for today, and in the next video we're going to get started on creating the logic for our boss fight using the systems that we've built up so far and some new behaviors. Until then, I hope you all have a great day, and I'll see you in the next video.